Okay, hi everyone. I wanted to mention that this video is going to teach you how to find whether or not you have a flash drive that's fake or real. The first one that I'm installing on my computer, or rather plugging in, is a 32 gigabyte flash drive, and I know it to be real. I've had it for a while. The other one I just got in the mail from eBay. It's a 2 terabyte flash drive. Yeah, now there are large flash drives on the eBay market, but this one is a USB 3.0 2 terabyte flash drive, and I got it for $14. So I really doubt that it's real. First, we're going to start with unzipping this file. Okay, so we're unzipping it now. As you can see, the files have been unzipped. Now what we'll do is we'll run a simple indirect within the same directory. We'll run a make file. That's right, I have to cd into that directory that I just created. And then make it. Okay, so it's made. I could install it if I want to, but I'm sort of weary about installing different tools that I download off the web, even though this is a safe app. It's made within that directory, so now we'll look and see what's inside. As you can see, there are a few different applications that have been made. They're highlighted in green. The two that we're focused on right now is F3 read and F3 write. Now, F3 read is made specifically for verifying data that you've already written through F3 write. F3 write just sees if what you've written is valid. F3 read takes that written data and sees if that data is valid. So basically what you're doing is double checking the data. And we'll do that right now. So before we do that, we're going to see exactly where our flash drive is on the list block. Okay. As you can see, we have a 28.7 gigabyte storage drive here. And if you look across, you can actually see how it's been mounted, or what it's been mounted as. It may vary, it will vary from user to user, but for now we'll just go with this. So we'll say ./F3 write, and then we'll do media name, and then of course the name of the mounted drive. And then we'll try it. Okay, as you can see here, it says removing old file. The reason it did that is because I previously wrote to this drive to see if anything had been tampered with, but apparently it hadn't been. So this is just what it does each time it runs the test. So as you can see, it's creating the file, each file, and each file that's created, it'll show how fast each file that's being written is transferring data to. And you can also see how much time it's going to take before that written data is complete, having all of it written. I'm going to pause this video until this is done, and then I'll get back to it. So see you in a bit. Okay, and as you can see, it looks as though each file has been written. I think each one is about a gigabyte long, which is why larger drives take a longer time. Don't worry though, we're going to use a different technique to write and read the larger drive. But for now, let's focus on what's important, reading the data that's been written to this drive. In order to do that, we repeat the previous command and then use read instead of write. Let's see how long this takes. Okay, as you can see, it's reading the sectors of each part of each gigabyte. This is going to take significantly less time, as you can see, 3 minutes, because we're reading it almost as fast as a normal SATA-based hard drive. It reads what's okay, corrupted, changed, and overwritten. I'll get back to this and get back with you after we pause this. Okay, as you can see, everything's been validated, and it looks like everything is okay with this drive. This is the real size of this flash drive. It hasn't been modified or changed in any way, so we know it's alright. Data lost, sometimes this will happen after old age of the USB drive. That's just my opinion or guess. I don't know if that's actually true. Corrupted, nothing's corrupted, nothing's been changed. Overwritten, nothing, and this is our average reading speed, as you can see, a lot faster than writing. In order to run the utility that we're going to use next, in order to probe the drive, the 2 terabyte drive, it would take a lot longer, days probably, to read and write data, or write and read, to a 2 terabyte drive. So what we're going to do is make extra. Oops. Okay, so apparently I didn't have the dependencies for that command. Hopefully this will work this time. Sorry about the pause. See if this works. Oh, great. I'll be right back. Okay, sorry about that. I think I had the final dependency fixed. Let's see if this works. Good, it did. Let's take a look at our new files for the make extra. Okay, so we have quite a few new files. The 2 that we're going to be focusing on are F3 probe, which will allow us to probe the drive and to see if we can get the program to calculate exactly how large the drive actually is, and of course whether or not it's fake. That takes significantly less time than reading and writing to it, especially if it's a large drive. And then we have F3 fix. I've never used this before, but we'll use it in this video anyways. Get to that in a moment. I'll be right back. Okay, I'm back. So just to show you, each one of my 2 terabyte hard drives on my computer is about the system reads it as 1.8 terabytes. Now this flash drive says 1.9 terabytes. Not sure if there's any significance behind that, but as you can see, it's still listed under SDE, still under media and name, and of course the partition, or partition name. I'm going to show you a man page that I discovered. Hold on a moment, let me close this. Yeah, here's the man page. So, quick capacity tests with F3 probe. F3 probe is the fastest drive test and suitable for large disks because it only writes what's necessary to test the drive. It operates directly on the unmounted block device and needs to be run as privilege. Okay, so to get that started, we need to unmount the drive first, I suppose, but geez, I'm really puzzled. Do I really unmount it? Okay, we'll try that. Yeah, it didn't require this the last time I did it, so that's why I'm sort of like, what? Let's see, the U-mount dev SDE. See if that works. Weird. How about SDE 1? Okay, that unmounted it. Good. Let's take a look at our block list again, see if it's unmounted. As we can see, it has been unmounted because the name of the partition is no longer to the right of disk and part. Let's do what the man page says and see how we run this. Okay, so we want to run /f3 probe destructive time operations dev sd, and you don't want to put b because that can actually destroy one of our other partitions. We want to use the partition that's being used. We don't want this at the end. So just be careful when you do that, or else you could destroy the data on your computer. I'm going to run this now. And then complete it with dev SDE. Let me just double check that man page. Okay, good. Alright, that made me a little nervous. Jeez. Okay. Really? Oh, have to use root, that's right. Okay, this is going to take a little while. Don't know how long. I'm going to pause the video once again. I'm sorry I keep doing that, but this is really time consuming and I don't want to waste your time. I'll be right back. Okay, and as I suspected, it looks like there's bad news here. The device SDE is a counterfeit of type Limbo. You can fix this device using the following command. So this is the command that we compiled earlier using make extra f3 fix. That's to fix this drive and turn it into its usable size. So usable size, what is that? It's 58.65 gigabytes. So in reality, I bought a flash drive off of eBay that was advertised for 2 terabytes, which is the announced size, give or take a few hundred gigabytes. And then the usable size is what it actually is, 58.65 gigabytes. This could be a bit of trouble. I've never actually tried to fix a drive doing this. Let's see if I can do that. And let's see if it works. Okay. Sorry, my password's a little long. Okay, so the drive was successfully fixed. Let's do an ls block one more time and see what it looks like. Let's see if this actually fixed it. Okay, it did fix it. So as you can see, SDE now is 56.6 gigabytes large. Geez. That's what $14 will get you, I guess. So, as you can see, it's partially being read as 1.9 terabytes, but the partition that program created is 58.6 gigabytes. Wow. Really got my money's worth. Well, I hope you enjoyed this video. I hope it was educational, and see you next time. Bye-bye.